This video is for the Lesson 4 activities, the first part of Lesson 4. We are going to start by solving a proportion that was included in the class demo. To start this problem, I'm going to recopy it. Our trick for solving proportions is to multiply both sides by both denominators. So my denominators are x and 3. I'm going to multiply both sides of the equation by both denominators. The denominators will then cancel. On the next line, we're going to carefully write out what's left. We have 2x. And on the right-hand side, we now have to make sure to include parentheses for the 2000 minus x. Then I'm going to continue to solve for x by combining my like terms. And working my way. In the next step, I'll divide both sides by 5, and x will be equal to 1200. In the next problem, we are going to set up and solve proportions. It's going to be important that we set up proportions to solve these problems. We're also going to be careful and define a variable. A 650 megabyte CD can store about 74 minutes of music. Suppose that we've already selected some music to record on the CD and 256 megabytes are still available. Use a proportion to determine how many more minutes can be recorded. Our variable, we're going to pick a letter like x. To define, we're going to use the fact that it asks us for how many more minutes can be recorded. So our variable will be x is equal to the number of minutes that can be recorded. This will answer the question. Next, we'll set up an empty proportion and start filling things in. So the two things that we have a ratio of are megabytes to minutes. So we're going to be consistent when we fill those in. We have 650 megabytes, then we're able to record 74 minutes of music. Our variable is the number of minutes, so that's going to go in the denominator. And we're wanting to know how many minutes we can record when there's 256 megabytes available. Once our proportion is set up, we're going to do our proportion solving trick, multiply both sides by both denominators. Our denominators will cancel, and we'll carefully rewrite what's left. 650x is equal to 256 times 74. Dividing both sides by 650, we'll find our x is equal to 29.14 minutes. The ratio of blue M&Ms to all M&Ms is 2 to 9. In a large bag, there are 77 non-blue M&Ms. How many blue ones are there? So we're going to find our variable x to answer our question. They're asking about the number of blue M&Ms, so my variable will be let x equal the number of blue M&Ms. We'll set up an empty proportion and put in our first ratio we have, which is 2 to 9. We're going to carefully label this. 2 refers to the blue, where 9 is referring to all M&Ms. Our variable x is the number of blue M&Ms. That's going to go in the numerator. The last spot we need is going to refer to the all M&Ms. So in order to have all M&Ms, we're going to include the blue plus the non-blue, x plus 77. We'll continue on with multiplying both sides by both denominators, canceling our denominators, careful use of parentheses. In the next line, I'm distributing the 2 to x plus 77, and we have is equal to 9x. We're going to combine our like terms and solve for x. x is equal to 22. So what we found, looking back at our variable, is that the number of blue M&Ms is 22. In a small hospital, the ratio of doctors to nurses is 1 to 2. There are 81 nurses and doctors in total. How many doctors are there? Again, we're going to use the question to define the variable. Let x equal the number of doctors. Then we're going to set up our proportion, and the 1/2 of it is the 1 to 2. 1 is referring to the number of doctors, and 2 is to the number of nurses. So x, our variable, talks about the number of doctors, goes in the numerator. Now we need an expression for the number of nurses. 81 in total, and x are doctors, so the number of nurses is 81 minus x. From there, we're going to solve our proportion by multiplying both sides by both denominators. So x is equal to 27. That is the number of doctors.